and I'm delighted to invite Martin Hedges to join me on the stage. He's the CEO of Neotech AMT in Nuremberg, Germany, and he'll be telling us about additive manufacturing of sustainable mechatronic systems.
Okay.
So, hi, Martin, and welcome on stage.
Thanks very much for the introduction and the invitation, the possibility to speak at this innovation festival. So I'd like to say a few words about additive manufacturing and sustainable mechatronic systems. We only have a short time to present, so the agenda is pretty short. I'll talk about manufacturing mechatronics using 3D printed electronics processes that we specialize in, focusing really on the sustainability. I want to show a proof of concept study to show something, a real kind of application. It's a little bit in the future, but to show that how the sustainability aspects play into the use of this technology, show how this printed lamp, this proof of concept is built, and then we'll have a summary. So just for those of you that don't know who Neotech are, we are a machine tool manufacturer. We are specialized in machine tools for 3D printed electronics. So we're coming it really from this angle. Developing the machines, developing the processes, developing the complete systems. So for those of you that aren't really so familiar, what is 3D printed electronics? Well, really, it's the addition of print electronics functionality, often in combination with classical surface mount devices, so picking and placing of those onto and into structural components in 3D space. And in this way, you can use this 3D printed electronics technology to make electronic and mechatronic systems. And we have basically two ways to go, and you see those kind of routes in the images on the bottom there. On the left-hand side, we take an existing structure made by classical manufacturing, in this case, injection molding. The thermoplastic, it can be casting, forging, composite structure, whatever. And we bring the circuitry, we print the circuitry in 3D space, we place the surface mount devices, we connect those electrically, we do the post-processing, so cure, sinter the inks, dry the inks, whatever, to make the mechatronic system. And then the image on the right-hand side, that's what we call the fully additive route. So there we're adding the electronics, but we're also building the mechanical structure. So we're using classical 3D printing methodologies to make the mechanics, and then we can integrate the electronics both on the outside and also on the inside of the structure. And you can see quite clearly on this X-ray image, I've got circuitry, I've got chips, there's some other components embedded inside the device. Okay, so that's really what 3D printed electronics is. And the reason that you use it, the three main categories, there's the design flexibility, moving from 2D into 3D space. There's the economics. You can reduce the part count. You can simplify the processing, materials efficiency, shorter process chains, automated manufacture. But today, in this presentation, I want to just look at a little bit of the sustainability side. So obviously, I'll show you some examples based on this proof of concept, how we reduce the materials mix by using additive manufacture versus sort of classical technologies that waste a lot of materials. They work subtractively. For example, with circuit board technology, you remove a lot of copper, you work subtractively. So there's obviously a deficit there. In additive manufacture, you're adding material where you want it, so that's beneficial. And then also look a little bit to sort of the afterlife of the components. Because you're simplifying the materials mix, you can automate the recycling. You can also bring the production onshore. So that means that you can reduce the amount of parts tourism. Again, that has a small sustainability and strategic advantage. So this is the proof of concept that we've put together to sort of show the benefits there. And we wanted to really look at it in terms of the circular economy. Now, there is this circular economy framework, 10R framework, where you have different levels of actions that you can take to make the products more sustainable. Moving towards a circular economy. In this particular case, we have benefits in looking at reducing, so simplifying the materials mix, reducing materials usage and waste, and also the R4 category, repairable. So we can actually, because we've got a simplified architecture, we have the potential to actually extend product lifetime many times over. So we delay recycling, we make the recycling easier, but we can actually have a multi-life product. And then, as I also mentioned in the last slide, you're simplifying, shortening the manufacturing process. So Let's look at this R2 aspect, so simplifying the materials mix. If we think about